Welcome everyone to the Southwestern Pennsylvania Energy Efficiency Roundtable. This is on combined heat and power for commercial buildings. And I would like to thank everyone for taking the time out of your busy schedules to log on with us today. A few logistics before we start. We have a chat pod where you can ask questions throughout the webinar. However, we plan on having the Q&A after the presentation. So if you want to save your questions until then, that's okay, or you can log them into the chat box. I am going just to wait a moment or two and have a couple people log in. Just make sure that everyone's ready when we start here. Just taking a moment. All right, we got a lot of people signing on. I'm excited. All right, let's push ahead to the next. So the Southwestern Pennsylvania Energy Efficiency Roundtable's mission is to help businesses and industry in Southwest PA to reduce energy costs throughout their buildings, to improve energy management and energy efficiency optimization, and to implement cutting-edge technology. The Roundtable provides a forum for large industrial and commercial energy users to share information and learn from experts on various energy topics, such as energy efficiency technologies to energy management strategies. Currently, the group is composed of First Energy, Duquesne Light, Nextent, Peoples, and the Energy Programs Office of the Department of Environmental Protection, and PennTAP, which is Pennsylvania Technical Assistance Program. We have also had contributing partnerships with Kia, Keystone Energy Efficiency Alliance, and SMC Business Council. We have provided past programs on compressed air systems, lighting controls, chillers. Typically, we have these presentations in person to keep on providing, though, the industrial and commercial facilities with opportunities to continue the professional development and provide platforms with resources. We have worked to put today's webinar together and future webinars. This particular webinar will showcase a major contribution that combined heat and power systems can make to advance your organization's mission, commitment to sustainability, and minimizing environmental impact. Next slide. So to start, I am Alana Colvin. I am an Energy and Environment Technical Advisor for PennTAP. While PennTAP supports all of Pennsylvania, I work out of the Pittsburgh area, performing energy audits, supporting grant applications, and working on community economic development projects throughout the counties. More about me can be found on the PennTAP website, but I would also like to introduce William Sapone with Peoples Natural Gas. Thank you, William, for attending today. He is part of our Southwestern Pennsylvania Energy Efficiency Roundtable. He serves Peoples Natural Gas in the Clean Energy and Transportation Department, the largest natural gas distribution company in Pennsylvania, specializing in grid, edge innovation, and net zero emissions in vehicle solutions. Thank you for joining us today.
Alana, thank you again for having us, and thank you to the Southwest PA Energy Efficiency Roundtable as a great platform to kind of share this type of information. It's now my great honor to kind of present Bruce and Rich. I'll give a quick bio since I know we want to get into their presentation. Let's start with Bruce. Bruce Hedman is the Managing Director of Entropy Research, which has 40 years of experience in energy technology research, development, and commercialization, and is a recognized authority in combined heat and power and distributed generation technologies, markets, and policies. He has worked extensively with public and private clients to analyze the opportunity for distributed generation technologies and identify regulatory and institutional hurdles to market development. He has provided technical support and strategic guidance to the U.S. Environmental Protection Agency's CHP Power Partnership, and is currently serves as a senior advisor to the U.S. Department of Energy's CHP Deployment Program. Thank you, Bruce, for joining us today. And Richard Sweetser has spent 48 years commercializing advanced energy, power, refrigeration, and HVAC technologies. Mr. Sweetser founded Exergy Partners Corporation in January 1998 as a consulting firm designed to capitalize on opportunities arising out of utility restructuring, and climate change in the energy and construction industry. Exergy Partners has developed an extensive commercial, institutional, and industrial network focusing on the integration of on-site power generation, energy recovery, and thermal energy management. Mr. Sweetser is a senior advisor to the US DOE CHP deployment program and the US DOE Mid-Atlantic CHP Technical Assistance Partnership, as well as the US DOE's Packaged CHP Systems eCatalog Coordinator. Mr. Sweetser has published numerous technical and policy articles, technical manuals, a book titled The Fundamentals of Gas Cooling, and was the lead author on ASHRAE's CHP Design Guide. So welcome both Rich and Bruce. Thank you for joining us today.
Yep.
Thank you.
Wonderful. I'm real excited to have you all today. Just today's objectives. I wanted to post these questions. Be thinking about these as Rich and Bruce go through their presentation. So combined heat and power, CHP. What is it? How does it work? Who is using CHP and does it make sense for your company? Where does CHP fit into your energy improvement plan? Also, they will be discussing how to research the technology and how to mitigate risks. After that, they will go into question and answer. So thank you guys, and I'll leave it to you guys to talk about the rest.
Yeah, since you don't see our faces, this is Rich Sweetser. You'll have to get used to our voice changes so you know who's speaking. I'm going to start us off, and basically what our agenda is focusing on is William asked us to give you a little bit of a briefing on CHP basics. I'm going to try and fly through that because I assume many of you understand what CHP already is. Dr. Hedman will talk about CHP trends, and then he'll also go into CHP tools and resources. I'll come back on and talk about the eCatalog, and Bruce will finish it up talking about the CHP Accelerator. So that's our agenda for today. So let's start with basics. Obviously what CHP is CHP is the combined production of heat and power from a single fuel source. Why are we interested in it? It's highly efficient. If you look at the graphic to the right, you can see basically a 75% fuel use efficiency versus about a 50% fuel use efficiency for separate heat and power. That's fundamentally the reason why CHP works. So basically, we can recover waste heat from process cooling, space cooling, and dehumidification, and we can use a variety of technologies and fuels. It's not just a single product. So there are two types of CHP. This is called referred to as a topping cycle, or otherwise conventional cycle. What you have basically is a prime mover, which here could be an engine or a turbine of some sort, driving an electric generator, creating electricity. And then you have the waste heat from that coming off to a waste heat recovery unit, creating some form of thermal energy, either hot water or steam, that can also be converted into chilled water. So you basically can provide thermal energy to a building. A bottoming cycle is a case where basically you end up with a fuel. You create typically through a boiler where you're creating energy that goes into a process. You can take the waste heat from that, and go through some sort of recovery boiler and go into a steam turbine. That's quite often used in large industrials as a use, and it's also used for woody biomass when you're converting woody biomass or other forms of biomass into an energy form where you can create heat and power. So what are the benefits? Well, we already told you the efficiency benefits. We showed you that earlier. But high efficiency also generally translates into lower operating costs, but it requires a capital investment. So that's the balance we have. Higher efficiency also reduces emissions of pollutants as well as carbon emissions. CHP can enhance reliability, improve power quality, because it can be used as a vehicle to where you can island when the grid goes down, and obviously when you have local generation, you improve the ability to have frequency and voltage control at your site. And also on-site power can reduce grid congestion and avoid extra distribution costs as well. So what do we have here? When we look at it from a essentially a end use perspective, you have various applications where you have industrial, institutional, even as small as residential, utility scale, as well as commercial scale. So you've got all of these variety of generic markets where CHP can effectively be applied. So from a prime mover standpoint, going back to the topping cycle systems and bottoming cycles, you have steam turbines, which you can see steam turbine capacities, typically can run in from the thousands of kilowatts up to 250 megawatts. You have combustion turbines, which in the micro turbine size run from 30 kilowatts to 1 megawatt, and combustion turbines can run typically from 1 megawatt up to 300 megawatts. Reciprocating engines, actually recip engines, you can see as small as 1 kilowatt in CHP up to about 10 megawatts, and fuel cells generally from 5 kilowatts to 3 megawatts. So that gives you some idea of what the power generation capabilities are that get deployed in CHP systems. Now, what makes for a good application? You have high thermal loads. That can be steam, hot water, direct heat, which would be considered exhaust gas heat for drying or CO2 enhancement purposes when you're dealing with greenhouses, and cooling or dehumidification. So if you have high thermal loads and high electric demand, and particularly high coincident thermal and electric loads, that's good candidates. We'll get into in a minute what that really means. And generally, you need extended operating hours. Really, it's got to be you got to plan for over 5,000 operating hours to have a viable economic CHP plant in most cases. Access to fuels. The fuels can be natural gas. Today, it can be renewable natural gas in the pipeline. It can be biogas. It can be other kinds of byproducts. And eventually, we will see a lot more RNG, renewable natural gas, and ultimately in the future, hydrogen, when you want to get down to or what's called green hydrogen, where you want to get down to zero carbon emissions through a combustion process. And you also need to understand what the electric rates, the gas rates, and the regulatory climate is. And as long as that climate is favorable, you're going to have a good application for combined heat and power. So again, if we go back to what types of industrial applications normally fit under this, you can see the list here. I won't read through the list, but generally they're well known. Commercial applications, data centers are not easy. They should be, but they're not necessarily a place where you see a lot of CHP. But a lot of these other places you will see CHP. And I think as data centers need to decarbonize more, and we may see a way to apply CHP to data centers as well. A lot of data centers that are in commercial buildings, though, do use CHP. So that's the differentiation. When I say data centers, if you use colo data centers, you don't see CHP. But if you have commercial buildings with data centers in them, you will see a number of with CHP. Institutional, hospitals, some schools, some K-12 schools, but normally more in the university and colleges, campus, a lot in wastewater treatment plants and correctional facilities. And you do see a lot in agriculture. As a matter of fact, in Pennsylvania, there's quite a number of both dairy farms as well as food processing that utilizes CHP. I just wanted to give you two just case studies in point. One in Hershey, which is an interesting one, and this actually happens to be the largest system that's in the eCatalog, which we'll talk about later. But Hershey Medical Center commissioned this project in 2018. It started, and it's a 7.5 megawatt combustion turbine, and it was really put in for two real reasons: where resilience and saving costs. And an interesting byproduct is they also reduce their carbon emissions quite a bit in this particular site. The slide deck will be made available to you so you can actually see this more detail. And this one happens not to be in Pennsylvania, but it's down near me in National Harbor near Washington, D.C. This is another interesting one. It's the Gaylord Hotel at National Harbor. And here you see 3 2-megawatt packaged CHP systems literally shoehorned in between the hotel, the conference center of the hotel, and the parking lot of the hotel. And these have been operating also since 2018. And they were put in for carbon reduction. They were put in for because it was economics. They were actually put in under an energy services agreement. So it costs the Gaylord no money down and save them money, 15% reduction in energy costs from the get-go, and provides resilience. So if the grid goes down, these systems will be up and running and providing energy into the Gaylord. So it was sort of a big win for them in all sorts of ways. So now we're going to shift over to CHP trends, and you're going to notice a marked change in my voice because that's Dr. Hedman speaking.
Thanks, Rich. I'm in the middle of a seamless transfer here. Okay.
Can you get it?
I'm not sure. Let me see. Okay, there we go. Just in case, Rich, what do you see?
I see it, but you're not in slide presentation mode.
Yep, that's where I'm going right now. Okay, that wasn't quite as seamless as I was planning. Good morning. Again, my name is Bruce Hedman, and like Rich, I'm an advisor to the DOE CHP deployment program. And my job today is really just talk a little bit about the CHP market and some recent trends we've seen in the market in terms of new market drivers, what are sort of the really active market applications now, and some technology trends as well. And then also, in addition to that, I'm going to highlight some resources and tools that DOE has developed for CHP, and really leading up to when Rich comes back and talk about one of our more recent tools, and I think a resource for engineers, design engineers, and users that are interested in learning more about CHP and seeing if it would fit their facility. So I'm going to start off real quickly with a look at the current status of CHP in the U.S. and CHP. There's 80.7 gigawatts of installed CHP capacity in the U.S. now at over 4,600 industrial and commercial facilities. So this is already a significant resource for the U.S. This 81 gigawatts represents about 7% of total generating capacity. And actually these systems represent about 11 to 12% of kilowatt hours produced, because CHP systems are really driven by the dispatch need of the site they're at. So they tend to have longer operating hours than, say, your average central station plant. 82% of this existing capacity is in industrial applications. 65% is gas turbine based when talking about technologies, but of the capacity, but over almost 60% of the number of installations, units out there use recip engines. And right now, 72% is natural gas, but there's 15% that's biomass, biogas, process waste, and we see that as a really growing area for CHP. What I want to do in this slide and the next couple of slides is really highlight some trends, and the market that's developed over the past 5 to 10 years is very different than that existing market profile I just showed you. We still see significant capacity being installed in industrial applications, your typical industrial applications. But over the last 5 years, it was 61% of capacity. And if you remember the existing fleet that's out there, industrial is 82% of capacity. And we see growing activity in what I'm calling non-traditional CHP markets. This is light industrial, commercial, institutional. If you look at this bar chart on the right, the top applications in terms of number of installations that went in the past 5 years, a very different sort of combination of applications than you see in that existing fleet of 81 gigawatts out there. Multifamily condos, apartments represented the highest number of installations that went in. So we see a growing interest and market growth in these non-traditional CHP markets. And because of that, you see also a move towards smaller CHP installations. These markets tend to use systems in below 10 to 20 megawatts. And there's a technology response to that. There is an increase in pre-designed, pre-engineered, pre-tested package systems that are being offered for these markets. And these systems are really sort of are designed to reduce the risk to the user and also reduce the installation costs by being pre-designed and pre-engineered and reduce cost and time to install at the site. Natural gas continues to be dominant fuel in the last 5 years. And some of the other things we've seen in the market is an increase in interest in integrating CHP with other forms of distributed energy resources, PV, energy storage, and also a real strong driver in terms of applying CHP for energy reliability and resilience, and particularly in critical infrastructure applications and microgrids. A little bit, I'm going to do a deeper dive into a couple of these market trends. And first one I want to talk about is the packaged CHP systems market. And again, this is sort of a non-traditional look at CHP. But in this bar chart on the right here, the blue bars for each of these market segments, the blue portion of the bar represents that 81 gigawatts of existing CHP capacity. The green bars represent the technical potential, and this is from a study that ICF did for DOE in 2017. And total technical potential is about 140 gigawatts of additional CHP, in existing commercial, institutional, and industrial facilities. And you can see while there is still enormous potential in your traditional industrial users of CHP that are on the left of this bar, you can just see the enormous potential for CHP in these non-traditional applications on the right. And again, these applications use smaller packaged CHP systems. A lot of these applications, these market segments, have limited CHP experience. There aren't as many systems around as in industry and experience with it. A lot of these organizations or companies in these applications have limited technical resources. They don't have a lot of engineering on staff like a large industrial would have. And quite frankly, there's been sort of in some of these markets, a history of issues with performance and CHP sales and service support. So while this is a growing market, this is a market that has a lot of risks perceived by both users and suppliers. And this is really one of the target areas that the DOE program is focusing on to try and sort of reduce risk and educate both the suppliers and the users about CHP and the products that are out there. And that's what Rich is going to talk about with the eCatalog. But again, these non-traditional markets have represented 35% of the capacity and 70% of the projects over the last 10 years. So this really is different than that existing CHP slide I showed in the beginning. I mentioned on that on the trend slide that CHP for resilience for critical infrastructure and for critical business operations is just a growing driver. Again, the digital economy, high needs for higher reliability, higher power quality, in almost any operation you have. But at the same time, we see increased incidences of grid outages that cause major supply and production disruptions, and with real consequences for health and safety of staff and clients and the community and continuity of business services. And this chart up on the upper right from NOAA shows the billion-dollar disaster events, the number of weather-related disaster events, the number of them by year since 1980. And this has been normalized to 2019 dollars. And you can just see the increase in the number of billion-dollar storms, and you start to understand the impact on business and critical infrastructure because of that. And CHP really is a proven and effective option for facilities to enhance their energy reliability, both electric and thermal, cooling and heating, and provide for these energy services before, during, and after emergency situation. The thing about CHP, as opposed to having a standby backup generator, a standby generator sitting there, which is an asset that you've spent money for but hardly ever run, CHP can provide the user with financial benefits through energy savings, every day, not only during a grid outage. And because it's operated all the time, and it has and maintained to operate all the time, they generally are more reliable than a standby generator when they're called on to provide islanding service during a storm. So we see this as a key driver for CHP in the market. Particularly for critical infrastructure facilities like hospitals, nursing homes, things like that. There's a lot of information up on the DOE and EPA website about critical infrastructure and how they've used CHP. But here's a quick case study of also an aircraft, an industrial site, and the impact of their CHP system during Superstorm Sandy, almost 10 years ago now. This is Sikorsky Aircraft in Stratford, Connecticut, almost an 11 megawatt gas turbine system, the steam generally for process heating and chiller. And this facility, the CHP system provides 84% of the electric, 85% of the thermal needs at this site. And when Hurricane Sandy, Superstorm Sandy came, this facility did not experience any power interruption. It maintained a low level, but it maintained operations during the entire time. And it also provided disaster relief to the surrounding community. It was a focal point for continuing helicopter services because it had power and things, and was used as a refuge for the employees and their families. They came in, were able to charge their cell phones. They were able to put medicine in refrigerators and things. So after that experience, Sikorsky did they looked at all their facilities around the country and around the world to see if CHP would fit and what the sort of resilience benefits would be because of that. Another market trend we see is certainly, everyone has heard about microgrids and the interest in microgrids, again, because they can serve as a way to maintain grid to a surrounding area that could be a community or a campus and a group. And CHP really is being recognized, I think, as a important resilient anchor for clean microgrids. CHP can provide this baseload power and thermal energy. It can support the increased integration of renewable sources into a microgrid and really support the move toward a resilient, distributed, more renewable grid made up of these resilient, clean microgrids. And just to show you a little bit of what's going on here, this is a database of microgrids that ICF maintains. And they're defined in this database as a group of interconnected loads and energy resources that can disconnect and reconnect to the utility. And a single CHP system by itself in a hospital would not be a microgrid, but a CHP system with a PV with storage in that hospital would be a microgrid. And if it had several buildings, it would be a microgrid. So that's how they defined it. But you can see here, of the over 200 operating microgrid systems in the US, 84 are incorporated CHP as their anchor. And if you look at the specific applications, community microgrids, education, healthcare, multifamily, correctional facilities that have a high percentage of CHP, those are the sort of microgrids that are relying on CHP for its resilience benefits. And that interest in integrating CHP with PV and storage and other distributed energy resources doesn't stop with microgrids. There's great interest in how to do that at the individual site, and interest in how to, and integrators that are starting to put combined systems together in product offerings to individual sites. And again, CHP provides the baseload energy, PV reduces grid demand and related emissions and peak hours, storage adds that flexibility to do the same thing when the sun's not shining shining, but periods of high demand. And the combination really can optimize CHP sizing and operation, further enhancing efficiency and reducing emissions. Just wanted to show you at least one microgrid example. This is a small microgrid, but it's in Fairfield, Connecticut. It's a municipal agency microgrid. It connects a fire station, police station, communication center, public shelter, and a cell phone tower in a advanced microgrid that's designed to stay up no matter what happens with the weather in Fairfield. And it's anchored again by the 60 kilowatt recip engine that is at the police station, which has extended hours and holding cells and things like that. So it has a kind of a consistent thermal load. One other trend we see in the market that I didn't highlight on that slide earlier is micro CHP. There's great interest by the natural gas and propane industries, certainly in systems smaller than 50 kW. There's a lot of products being worked on and commercialized. The smallest are residential units that seem to be integrated with water heaters. But again, these target markets include light commercial, large residential, restaurants, retail stores, laundries. And this is an area I think to keep a watch on. And you'll see that some of these are in the eCatalog that Rich is going to talk about. The final trend I'll go through very quickly is natural gas, CHP natural gas, and decarbonization. I think everyone knows that decarbonization is a major topic in many states and cities. And in some areas, it has resulted in a push against natural gas expansion. There are 20 cities in California and the Northeast that have banned natural gas in new construction. I think it's 21. San Francisco just announced that a couple of days ago. There's efforts to stop investment in that infrastructure, and it certainly has affected natural gas. New York is natural gas CHP, and New York is an example of that. And I think part of the need here is that the CHP industry really needs to tell its story about how CHP can fit in this decarbonized world. And part of it is CHP can provide emissions reductions today. This is a chart we've put together that compares a 10 megawatt gas turbine CHP system to a 10 megawatt utility PV system, a 10 megawatt wind system, and a utility wind system, and a 10 megawatt sliver of 100 megawatt natural gas combined cycle system that would be sort of the marginal generation on a lot of the grids. And you can see for each of these resources, there's capacity factor, 85%, which actually, if it's an industrial CHP, is probably on the low side. These are for PV and wind and natural gas combined cycle. These are from the Energy Information Agency, the average yearly national average capacity factors. And you can see these 10 megawatts of capacity generate varying different amounts of annual electricity because of the capacity factor. Only CHP provides useful heat at the same time. And that results in the fact that CHP, a fossil fuel technology, actually ends up saving annual energy in million BTU, annual energy savings, on par with the 10 megawatts of PV, the 10 megawatts of wind, and the 10 megawatts of on the margin combined cycle, and CO2 savings and criteria emission NOx savings on it. And so again, CHP, even though it's natural gas based, is saving as much energy and CO2 today when it goes into a hospital or an industrial facility as PV, wind, and the best natural gas generating technology that's out there. And we just see that, and it's because of its net electric efficiency, its high annual capacity factor, that it can do this. And natural gas and CHP in general is more efficient than state-of-the-art natural gas marginal generation, that combined cycle system. And what that means is CHP can save greenhouse gas emissions now. As the electric grid decarbonizes, we see that marginal generation will continue to be served by natural gas combined cycle units in most areas of the country. CHP is the most efficient way to generate power with natural gas. As this chart shows, this compares the electric efficiency, the fuel chargeable to power generation for 4 CHP systems compared to a central station natural gas combined cycle and a central station simple turbine, cycle turbine. So CHP is the most efficient way of using natural gas to generate power. We've shown in microgrids that CHP can support greater integration of renewables into the energy system. CHP efficiency, emissions, and resilience advantages will remain, we think, as natural gas decarbonizes over the future through RNG and hydrogen. And in fact, RNG, hydrogen fuel CHP in the future can end up decarbonizing facilities that need some sort of fossil on-site generation for resilience or industrial processes that are going to be hard to electrify. So I think there is a story and a message about CHP being able to save greenhouse gas emissions now and in the future that the industry really needs to get out there. I'm going to quickly go over some tools and resources that DOE has developed to help users and design engineers look at CHP. And the first thing I want to talk about are the 10 regional combined heat and power technical assistance partnerships. These are funded centers at 10 regions, some of them universities, some sort of energy efficiency centers. You can see the regions and the states that are impacted by each. And the CHP TAPs really are there to offer fact-based, non-biased technical information to end users and to policymakers and to other stakeholders out there. And the other thing they do is the CHP TAPs work directly with end user sites to screen for CHP opportunities, as well as provide advanced services to sort of maximize the economic impact of CHP. And this is just, I want to highlight the screening approach that they do use, but the TAPs will work with end users to do a high level screening to determine if a site shows potential for CHP project. Ideally, it entails a discussion with the site, and entails ideally the site sharing 12 months of gas and electric bills and maybe some information about how much of that gas consumption goes toward a thermal use that could be addressed by CHP. And the TAP will walk through and do a quantitative analysis that would look at what the cost would be and what the potential energy savings and payback would be in a rough sort of system sizing, because the costs really are a function of system size and system type. And also they'll go through a qualitative analysis of trying to understand the project drivers and some peculiarities about the site, such as, is the site going to be replacing boilers or major equipment in the near term, which might be a real entry for CHP work. So this is one of the, I think, key services that the TAP performs. And this is the TAP for Pennsylvania. It's the Mid-Atlantic CHP Technology Assistance Partnership. It's at Penn State University, and its director is Dr. Jim Fryhot, and there's a contact information. And as a setup to getting back to Rich Sweetser, there are a lot of DOE, a lot of CHP resources up on the DOE website. There's an installation database that's over on the upper left that actually includes all those 4,600 sites that have CHP. You can sort by application, you can sort by state, you can sort by fuel, and you can sort by technology. Below that, there is a project profile database that has over 200 2 to 4 page project summaries, case studies of specific applications, specific installations. The case studies that Rich and I showed came right from that database. And again, you can sort by location, you can sort by application. There are fact sheets that have sort of standard national numbers of performance by size for recip engine CHP, for gas turbine CHP, cost, sort of national base capital costs and O&M costs for those kinds of technologies. There are policy program profiles that talk about incentive programs that are used in certain areas. Just a host of information that you can access through this URL up above, and also through the Packaged CHP eCatalog, which is one of the key resources in the DOE's portfolio here. And with that, Rich, I am going to turn it back over to you.
Thank you, Bruce. So I assume you can see my screen now. We're basically going to get into the eCatalog. I just want to give you a brief bit on background, a couple of key definitions, and then we'll go into the live demo. And as Bruce talked about, and we talked about earlier, the real reason for the eCatalog is to reduce risk. It's to reduce risk to all parties that are engaged in the systems, CHP systems under 10 megawatts right now. So this didn't start in a vacuum. NYSERDA, New York State Research and Development Authority, in 2013 started the concept of moving away from individually designed systems for each project to package systems and applying package systems or adapting packages, standard packages to projects. And they actually ended up doing several things. They saw the endorsement in this case of NYSERDA, or the recognition by DOE in our case, is important as far as getting the performance and analytical data correct. They also saw single point responsibility for the customer vendor relationship is key. We have the ability in the eCatalog to do either what we call packagers or solution providers. The solution providers are the single point responsibility for all things. Comparison shopping was critical, and begin to commoditize the offerings with the expansion of the use of options, that whole concept. They also saw that the eCatalog was not sufficient, that outreach programs such as public events, education, pre-screening projects, technical assistance, and access to financing, navigating, permitting, identifying supporting resources were all critical. And Bruce will talk about that when he talks about the accelerator. And they actually saw project cost reductions and time compression in the order of about 20% each during the course of the 2013 and 2017 timeframe that they focused on this particular program. Few definitions. Basically, again, we're doing this to reduce risk, and we see our target audience being basically design engineers, end users, utilities, energy service companies, federal agencies, all will be the end users of the eCatalog. Our principal players in the eCatalog are packagers. They are reviewed and recognized by DOE as having the capability to do the packaging. And the solution providers, they are the ones that can do commissioning, install. They may be a packager, may not, and they offer the minimum of 5-year maintenance and service agreements. And customer engagement partners. Customer engagement partners are utilities, energy service companies, basically that basically have CHP programs or that move CHP into the marketplace. Just some statistics. This was launched in November 19th of last year. Currently, we have 34 recognized packagers, 22 recognized solution providers, 10 customer engagement partners. We got a total of 267 package offerings in there right now. They span from 24 kilowatts to 7.5 megawatts. And currently we have thermal offtake at hot water, steam, chilled water. We've just added the capability to do direct exhaust gas. That'll be coming in here as well. So I think without further ado, we're going to launch over into the eCatalog. And let me get my taskbar here so we can head up to the eCatalog. And what you see here is the homepage. The homepage basically describes this issue of what we're trying to do as far as reduce risk. And you'll be able to see that in the text here. Up here, if you need to create an account, you go to sign in, becomes pretty simple. You can, whoops, wait a minute. Sorry, I apologize for that. I was logged in. You go to sign in and you can just create an account. It's really self-intuitive. But I wanted to run through these particular main tabs so you get an understanding of what the user experience is. I'm going to skip over the search for a minute because that's where the meat and potatoes are. The site guide has all the different elements of the catalog that you need to find out. If you've got a question, if you can't find it here, you can send us a message. The first tab of interest is benefits. Obviously, we talk about the benefits of packaged systems here. But more importantly, all those assets that Bruce described as far as fact sheets, project profiles, databases for CHP, it's all available right here. You get direct links. You don't have to look anywhere else if you don't want to. Financing page. Financing is a very interesting part of CHP projects. Obviously, we're traditional financing everybody knows about, but in this area of specialized financing over here, you have energy as a service, energy service performance contracts, power purchase agreements, and we have an emerging group. And the state of Pennsylvania does allow what's called CPACE, which is commercial, and it is basically property tagged lending, which allows you to extend out your terms of loan to somewhere around 23 to 25 years, and it's basically at the usually at the municipal bond rates. So it's a very low percentage rate, and the payback actually happens through your tax collection vehicle, the payback of the loan with the interest, which is rather interesting. So you get a lower cost of loans, and this is done in the state of Pennsylvania by, I believe it's by county. So you'd actually have to look at your local county or municipality to see if they've actually implemented CPACE, but it's allowed within the state. Also, we highlight projects that have been done by each of the financing steps and allow some assets down here if you need to find out our financing primer. We also have access to the Better Buildings Navigator, which you can find out who currently is financing energy efficiency projects. And you can come down here and actually connect with the financial allies in that regard. Now, this tab will show you the recognized packagers that are in the eCatalog right now. Basically, you have virtually everybody with perhaps the exception of Cummins, then they're in the process of joining right now. And if we've missed somebody, there may be one or two that we need to get in here. You can get direct access, and whoever you want to get direct access to, you can come down here, find their description, and get direct access to the company for ease of access. So then, solution providers. Now remember, these are the folks that they may be packagers, but they also offer installation, commissioning, and a minimum of a 5-year service and maintenance agreement for the entire system, whatever they're offering. Same way, you get access to those folks through here. And you can, by the way, down here, you can find out what they have committed to, what the requirements are to get in here. So you can see it's not just an easy lift for people to become recognized in the eCatalog. So again, that builds a lot to the credibility. Our customer engagement partners are located here. And you can go in and look. And again, we have a familiar face here. And you can get direct access into people's program by accessing down here on the website. Now, I would encourage you, if you don't see someone here, which we don't have a lot of PA folks here yet, it would be nice if you encourage the utilities to get engaged. And obviously, we would be interested up in this area to have DEP or someone from the state engaged as well. And if they're online, please contact me. And then over here, we have the taps, and that we already talked about the taps. So without further ado, let's head into the meat of the eCatalog, which is right here. You can see I have results here because I put in a zip code. I happen to put in Carnegie, Pennsylvania here as a zip code. And you start to get results of various systems that are available. Now, you will notice, interestingly enough, you have an AB Energy product here, and you have, if you look carefully, a similar product that looks like another AB Energy product, which is offered by Cogen Power. That's because they're offering, they have an agreement between each other where they can offer the system. So the services that actually are provided by AB and Cogen may vary. But you'd have two different opportunities to look at that same piece of equipment, or you can go down and pick up whatever else you're looking for. Now, just to give you a general idea of the Amazon eCatalog, you come down this gray bar to the left. This is where you begin your selections. If you're okay with just getting a packager and you don't need somebody to install, what we're going to do is we're going to prioritize the selections by packager. If you want a solutions provider that offers commissioning and such, here, you can actually go down to an assurance plan, which adds to all the other standard things, an availability, minimum availability, as well as a maximum response time to an unintended outage. And you can actually come down here if you want to get solution providers that are offering energy services, such as a power purchase agreement or energy service contract. Moving on down, you can prioritize by customer engagement partners. In other words, if someone has created been accepted by the local utility or energy office in a particular program. The next is you can start the meat and potatoes. I want to put a megawatt system in here, so that's going to that will change the selection process. And for some reason, I am not changing. I've got to go back up here. Let me go and do that one more time. Yeah, now I put 7,500. I want 1,000. You go in and you start clustering units around 1,000 or 1,000 kilowatts. So you really get a range of 700 kilowatts to 1,200 kilowatts. And you have the ability here to consider multiple units. So you can have multiple units applied to that as well. You can, if it's outdoors, you can require outdoor installation. Fuel types, we have natural gas or RNG propane, or RNG pipeline gas, propane, digester gas in here right now. Interconnection, grid parallel or grid islanding, various thermal outputs, prime mover type if you want to specify, packaged in the US. And if you have a footprint limitation, you can put that in. All of that will give you what we call an equipment card solution. Each of these cards, you can see down here, I've got 2 full matches, and then I start with high matches. They're in batches. So you go 100% match, high match, match, and partial match will be the batches. And they will actually rotate because we don't have, Martin Energy will never be first all the time. It'll rotate by each bin. So within each of these cards, you've got a great deal of information. You'll have the power, the thermal, the fuel, prime mover, and grid. But up here, which will appear down below here, you end up with, is it available? I mean, can it be legally sold there by the company, such as through distribution? Is it offered by a solution provider? Is an assurance plan does it offer an assurance plan? Is it supported by the local utility or energy office? Is it suitable for outdoor installation? Does it fit within a footprint if it's required? Is it packaged in the US? Number of installs, I'll show you. That's the blue one. Like here, a lot of them haven't put their installs in yet, but you've got 1,245 AB Energy systems that have been installed worldwide. So you know that they have a fair amount of experience in knowing how to build those packages. And then if you're logged in as a user, you have the ability down here, a tab will appear where it can be a favorite and you can select them and save them literally project by project by project and have an unlimited series of projects saved to your dashboard that you can recall and refer to and change if you need to. Then the next element you come down to is actually I can do it here. If you hover over one of these, you can see view details. Because I'm not logged in, it's saying, hey, wouldn't you like to log in? I'm just going to say, no, thank you. You should never do this. you should always create a user account. So this you get your basic picture, you get the general information that you've had on the card here, and then you get a whole host of information. You get descriptions on Martin Energy is a solutions provider and Martin Energy is a packager in this case. They haven't entered their data in yet. We have to do that. So you would get the company installs by Martin Energy, total company installs actually I have in Washington, D.C. Was the zip code that just went in at the end. Installs of this package and company installs of this package. So you get a whole host of information on their actual experience by installations. Here's where you get information you won't find anywhere else in the world. You get power information at 100%, 75, and 50% gross power, and 3 ambient temperatures, 95, 59, and 0. So you get the power, and you get the net electric efficiency and higher heating value. And then you get the hot water supply. Now we do a standard. So DOE standard for hot water is 180-degree hot water delivered. You may have 190 or 200 degrees, whatever. But what you will know, you can depend upon the hot water capacity. You know what the capacity is, and this is based upon 180-degree standard. Chilled water is based on 5444 chilled water, 85 condenser water. Steam is based upon either 15-pound steam or 125-pound steam. And for direct exhaust gas, there are 2 exhaust temperatures, sink temperatures. One's 140-degree Fahrenheit. That's for glass greenhouses. If you're going to put CO2 enrichment and heating in a glass greenhouse, the other is 200 degrees if you're doing general process drying or heating. Further down, we require NOx and CO emissions. They may give you some more emissions than that. And then there's other information, including weights and dimensions. And then there's a simplified schematic of the systems that are provided in the package. And this can all be saved. It can be downloaded via PDF. And and down here on the right, you get direct contact to in this case, to Martin Energy, description of their assurance plan, technical assistance. If Peoples would support this system in Pittsburgh, you'd get Peoples information here as well. And if there's an energy office program that has accepted this package, that would be there as well. Since my friend Dr. Henwood went a little long and I've got 2 minutes left, I'm going to turn it back and go back into the slide deck so that we can finish this up properly on time. And give me 1 second. Bruce, do you want to quickly word on the accelerator?
Yeah, very quickly. Rich mentioned before the demo that the key to the success of the catalog program in New York and NYSERDA was the market engagement plan and the education and outreach and technical support activities that went with it. Recognizing that and then developing and funding the eCatalog, DOE put a partnership together. It's a high-level partnership that's called an accelerator partnership. And it's a partnership between DOE and utilities, states, efficiency implementers that are interested in promoting CHP and packaged CHP. And it's really built around the eCatalog. And the objective is to populate, launch, and publicize the eCatalog. And again, it's a partnership to push packaged CHP to provide outreach on the eCatalog. And I have to say that Peoples Gas was one of the initial members of the accelerator, and William Sapin has been a real real champion for the eCatalog and the accelerator.
Okay, since we don't have any time for questions, I will say that we'd be happy to go through the eCatalog with anybody one-on-one if they want to find out more information. So I'll turn this back to Pentap.
No worries. If some questions have popped up, and I do want to address some of those, and if people do have questions, that's okay. I would like to see what they are, and that way too we can send them out if people have to jump off or what have you. So questions are all fair game. What I wanted to ask is the slide deck available to participants? So would you guys be okay if I sent this out to the participants?
You betcha.
Absolutely.
Just send it out in PDF version for us.
Yes. So that would be made available. Also, can we get the names and info from the participants? Do you guys share your info, or do you rather people go to a specific site to get more information?
You mean Bruce and I?
Yes,
Yeah, no,
you
we
guys.
can
No,
share
we'll
it.
be happy to share that.
Yeah.
Go ahead.
Okay.
Yep.
So we'll share that along with this, and then all of the Southwestern PA participants, our information is on a later slide. Before we jump to that slide, though, I do want to highlight that there is one more Combined Heat and Power webinar that we're going to host on December 9th. This one will be an operators panel. We will have speakers from Allegheny Health Network, Joule Design, and MCR Performance Solutions. They will be talking about their experiences from the installation, the design of the equipment, the process of install, but also the usability and what people see and why they decided on the project that they had installed. So please sign up for that webinar. That one will be a lot of great conversations, case studies, and questions asked from everybody else. Question, do you need a CHP eCatalog account to use the site that you guys shared, the eCatalog site?
No, the answer is no. You can go through it. The only reason I recommend you become a user, and all you need is a username, a password, and your zip code, and you're a user. So it doesn't really take very long. That's all you do, and that gives you the ability to save any of the queries that you make. I would recommend you do that, but you don't have to.
Wonderful. With that, I don't see any other questions at this time. If you could forward the slide.
Yep.
So as mentioned, this is the contact list for, we have DEP, Nextent, First Energy, Peoples, Duquesne Light. And then also, if you don't mind pushing the slide one more time.
Whoops. We'll do that one more time. There you go.
All good, all good. This is my contact. So again, Alana Colvin with PennTap. We are part of Penn State. If you guys, anybody on the call would be interested in talking with the TAP for CHP at Penn State, we can absolutely help out people there as well. So just wanted to highlight that. We have a lot of information to share. Thank you everybody for joining us today. Like I said, if there's any other questions, you can email me, you can email these guys, or however you want to get that question out to us, we'll get you the answer. So I really appreciate your time, Bruce, Rich, and William. Thank you so much for signing on. And with that, we'll conclude our webinar.
Thank you, Alana. Thanks, everyone.
Take care.
Thank you.